So, welcome to my last segment of this small concept. We are focusing on hydrates, how to determine, the formula of a hydrate. If you're doing pure science, this is a good discussion that you need to focus on. Sometimes you find such questions that they are going to ask you. So, what exactly is an hydrate? Well, and when we talk about a hydrate, it is simply an ionic compound that contains water molecules in its crystal lattice. E.g., I can simply say if you have a compound, maybe we are saying MX, it should have some water molecules incorporated into each. Maybe let me say n number of water molecules that you have. So this is what we are talking about as being a hydrate. So it's simply an ionic compound that contains water of crystallization in its molecule. Now, of course, remember that in order for us to determine the formula of such a hydrate or to determine the number of water molecules, first of all, what we can do, we can take, the hydrate. We can take the hydrate with n number of water molecules and we heat it completely to dryness such that it becomes an hydrate. The idea is we want to get rid of all the water molecules. So when we get rid of all the water molecules, we are going to remain with the anhydrous salt. Then all the water molecules are going to be, released from the hydrate that we have. So when we have that, it is now possible for us to determine what the value of N, the number of water molecules that you have. So what's the formula that you can apply in order to find N, the number of water molecules? Well, in order to determine the number of moles N, you can simply apply the formula, moles of water. So we are going to be using the formula moles of, water, in this case, moles of the H2O, divided in this case by, the moles of the compound, the anhydrous compound that you're having. So that can help you, to find N. So you're going to find that we first of all determine the number of moles of water and also determine the number of moles of the anhydrous compound. Then we are going to now find the number of moles of N that is in the water molecule completely by dividing the number of moles of water divided by the anhydrous salt. Well, let me show you by looking at a few examples that we are going to deal with. With me, I do have some sample questions this side. So we'll focus on a few sample questions that we are going to deal with. So I've got two questions that will help us to actually answer, such a question in an exam. So the first one there simply says, a sample of a hydrate of chromium 3 chloride with a mass of 3.572 gram was heated until no more water was released. The mass of the resulting anhydrous means a salt without water, was 2.663 grams. Then the question says determine the formula of the hydrate. So what are we going to do in order to solve that? Well, the first thing that you need to do is simply for you to write the equation representing what is being talked about. So they are talking about, chromium 3 chloride in this case. So chromium 3 chloride, the proper formula that we are going to have is simply chromium 3 chloride. Chromium has a valence of 3, chlorine has a valence of 1. So that is, the salt. But because it is a hydrate, meaning that it contains water of crystallization, I'm going to assume that the formula is going to be CrCl3. Then we have got n number of water molecules incorporated, which we don't know. But of course, when it is heated to dryness, we are going to remain with the chromium, 3 chloride. But what is going to be released is simply the number of water molecules. Now, if you go back to the question, they told us what was the mass of the hydrate. It was simply 3.572 grams. And after it was heated such that all the water was released, they told us the mass of the anhydrous the salt without water, it is simply 2.663 grams. Now, if that is the case, we can know what was the mass of the water that was released by simply getting the total mass of the hydrate, which is 3.572. We subtract that of the anhydrous, which is 2.663. That's what we can do. So it is going to give me here the mass of the water that was ejected is going to be, this is going to give us in this case 0.909 grams. So that is the mass of the water that was released. So what's the next thing that we are going to do? Well, we need to first of all find the number of moles of in that mass of water and the number of moles in this mass of the chromium 3 chloride. So I'm going to start and simply say the number of moles in the H2O will be equal to, remember, number of moles is equal to mass over Mr. Of course, when you calculate, in this case, the mist of water, it is actually 18. So the mass there, you get that mass there, 0.909. You divide by the mist of water, in this case, which is 18. So what will that give us? If you divide 0.909 divided by 18, it is going to give us, in this case, 0.0505. So these are the number of moles of water molecules. The same is also going to be true. We need to find the number of moles. We need to find the number of moles in the chromium 3 chloride. So again, it will be the mass divided by the mist of the chromium. So the mass of the anhydrous is simply 2.663 divided. If you calculate the mixture of that, it is simply going to give us 158.5. So 158.5. Therefore, when we divide 2.663 divided by 158.5, it is going to give us, we can leave it to maybe four decimal places. It is going to give us 0.0168 moles of the chromium 3 chloride. What next do you do? Well, you apply the formula that we talked about. Remember what we said there? In order to find the number of moles n, we simply said it is simply the moles of H2O divided by the moles of the anhydrous salt. In this case, we are talking about the chromium 3 chloride. That's what we mean. So what will that give us? Well, it is going to be, we get the number of moles of water that we got, which is 0.0505. We divide by the number of moles of chromium, which is 0.0168. So if you get that one, 0.0505 divided by 0.0168, you are going to have, as a whole number, it is simply going to give you 3. So the number of moles N, that N in the formula there for the water is actually a 3. So therefore, we can simply say the formula is going to be, it is going to be chromium 3 chloride dot 3 water. So that's the formula. So we have got, in this case, 3 water, so tetra water. That is what we are having. So it's chromium 3 tetra water or 3 water. So that's the formula of the hydrate that they gave us. Let's move on and look at the second question and show you how again you can go about it. But of course, if we look at the second question, it is slightly different in the sense that they have given us the percentage. So let's look at question number 2. It says a hydrate of sodium hydrogen phosphate was found to contain 47.05% water by mass. Determine the formula of the hydrate. So what are we going to do in this case? So we need first of all to write again the formula. So they have told us it is sodium, hydrogen sodium hydrogen phosphate. In fact, I was supposed to give you the formula there. So the formula that was supposed to be there was Na2HPO4. So that's the formula, sodium, hydrogen, phosphate. So that's the formula. But because it's a hydrate, maybe I can say X water, so we don't know the number of water molecules. But when this is heated to dryness, you are going to have the sodium hydrogen phosphate there being produced plus XH2O. That's the number of water molecules. Now if you remember, they told us what was the percentage of the water by mass that they had. They told us that it was 47.05%. Now the whole thing, it simply means the whole hydrate was simply 100%. So we can know what is the percentage of the anhydrous salt. So we just say 100 minus 47.05. So that is going to give us 52.95%. That was for the anhydrous salt. So we do the same. We are going to find the number of moles of the H2O of the water molecules. So the number of moles of the water molecules, which in this case will be 47.05. You simply divide by the mixture, which is 18. So get that percentage divided by 18. If you divide 47.05 divided by 18, it is going to 4 decimal places. It will give you 2.61, 39. That's what you're going to have. You also do the same in this case by finding the number of moles of the salt. Let me just write the weight here, the salt. So this is the salt we are talking about. So what's the percentage? It is simply 52.95%. You divide by the mixture. Well, if you calculate the mixture of that guy, it is going to give you 142. So now once you calculate 142, and we can now divide this one, so it will be 52.95 divided by 142. So the mixture of that compound that we are having there, so it is giving me in this case 0.3729. So remember, these are the moles that we are having. So the next thing, you can find what the X in the hydrate there indicates. So to find X there, you're simply going to say the moles of water. So you're going to say again the moles of your H2O divided in this case by the moles of the salt that you're having. So it will be 2.6139 divided by 0.3729. So what is that going to give you? So 2.6139 divided by 0.3729. What is that giving us? Well, it is just giving me a 7. Therefore, I can conclude and simply say, well, the formula of the hydrate is simply Na2HPO4 dot 7 water. So remember that dot is indicated just to separate the salt and the water incorporated into the lattice crystal. Thank you so much. So this is the way you can go about that. We'll see you in my other videos as we talk about other concepts. Thank you for watching.